Hello. Namaskar and good evening, everybody. My name is Sanjay Deshmukh, and I work as a professor of life sciences in the University of Mumbai. This is a wonderful opportunity for all of us to look at one of the most important species of plants, which is actually contributing to almost two-thirds of the livelihoods of the global population. And that is surprisingly a grass species, which is also called poor man's timber till recently. However, this poor man's timber has proved to be very, very important with regard to supporting not only livelihoods but also providing opportunities for the scientists, policymakers, as well as common man to look at climate change solutions by sustainably utilization of the resource as well as supporting the livelihoods of rural and urban sectors alike. Today we have IIT Delhi and one of the very prominent NGOs in bamboo sector and also in the sector of livelihood security of rural communities, KONBAC. They have come together to organize one of the very important webinars providing opportunities for all of us to look at contribution of bamboo and its utilization with respect to construction, that is its role in construction material. And we have four very prominent speakers who will be highlighting the research that they have been conducting with respect to this particular sector of bamboo construction. It is not only construction but also the research that has gone in with regard to utilization of bamboo in this sector as well as its usefulness both at rural and urban levels. Bamboo as a material comes in various diameters, and in India particularly, barring few areas like northeast region as well as states like Kerala and Karnataka, bamboo does not grow beyond 2 to 4 inches in terms of its diameter. And therefore, the locally available bamboo and its utilization for construction is a very, very interesting and important topics. So we have four speakers who will be highlighting the role of bamboo in construction sector. The first speaker will be one of very senior scientists from Forest Research Institute, Dehradun, Dr. Sadhna Tripathi. And she will be starting with her first presentation, followed by we will have Dr. Vipin Chawla, who is from IPIRT, one of the pioneering research conducting institutions of Ministry of Environment and Forest based in Bangalore. This will be followed by Shri Sanjeev Karpe, an electrical engineer by profession and also a founder director of KONBAC, who is collaborating with IIT Delhi today. And we will have a concluding presentation by Dr. Supratik Gupta from IIT Delhi, one of the main organizers of this event. And Dr. Gupta will be not only talking about the role of bamboo in construction with respect to concrete material developed with the help of bamboo, which he calls at bombcrete. And he will also discuss policy matters with respect to this entire gamut of today's program. So I would like to invite Dr. Sadhna Tripathi, Scientist G from Forest Research Institute, Dehradun, to open this particular session by her presentation. Dr. Tripathi.
Good evening. Thank you, Professor Deshmukh, for inviting me for this presentation and to share my work with the audience and the intellects and the academicians who are in the field. So today I'll be talking about bamboo preservation, which is very much required for protection. In fact, I am working in Forest Research Institute, Dehradun, which comes under the minister under Indian Council of Forestry Research and Education, which is an autonomous body, and it is under MOEFCC, that is Ministry of Environment, Forest and Climate Change. And we have a organizational structure, like we have a director general in the organization, and after that the work is looked after on extension and education and various aspect research by deputy director generals, and they are assisted by the additional director generals. And now we have institutes all over India. We have 9 institutes and 3 centers. We have presence all over India. So Forest Research Institute is one of them, which is located in Dehradun. And our headquarters is also at Dehradun, that is Indian Council of Forestry Research and Education. In fact, this Forest Research Institute is not a new institute. This is a premier institute who has reported work on various timber species, plantation species. I mean, all aspects of the forest they have covered. So I would like to have my presentation on the screen so that I can share my work with the audience. So as you can see that today I'll be talking about durability improvement of bamboo, a versatile material. The topic is self-explanatory. You can see the durability. You can just assess what is it. And of bamboo, since we are talking about the bamboo, so we'll be focusing on the bamboo only, and it's a versatile material. I mean, for variety of uses, you can use the bamboo. And I have already, talked about our organization structure. Next one, please. So you can see our presence. Previous one, please. You can just see our presence, the presence of our organization all over India, like in Shimla, in Dehradun, in Bangalore, I mean, you can have a look on the slide. You'll get the idea. And every institute is focusing on a particular sort of mandate. So we are focusing basically. Next one, please. As you can see that this is the core competence of the Forest Research Institute. Since I belong to this institute, so I'll be talking about this. And I am placed in the Forest Products Division, which deals with the timber and timber products. And our work starts after the harvesting takes place. And before that, we have the Forest Entomology Division and the Forest Pathology Division, which works on the type of the insects and pathogens which attacks and decays the any material, wooden material or the lignocellulose of the bamboo. And but we work on the forest products, mainly on the utilization aspect. Next, please. So next, please. So you can just have a look on the slide. We are working. I am for the last 25 years. I am working in the wood science and technology field. Basically, I am a chemist. So now we have a department like timber mechanics. You can get the idea that all sorts of testing of the wood or bamboo we take up in the department, and we work on the bamboo utilization from the structural point of view. Like we have categorized the bamboo into different sections, like class 1, class 2, class 3. The class 1 deals with the structural type of the bamboos, which is based on the set of the procedures for which it was tested. And similarly for the, like if you talk about the strictest, Dendrocalamus strictest, quite strong bamboo, it cannot be used for, I mean, it cannot be recommended for handicrafts. It is for construction purpose. So there must be some scientific basis for that. So they worked on that. And next one is the wood seasoning department, which was established in 1947. You can just see that 1947, 1914. They work on the drying of the bamboos as well as the wood, so that they give the preliminary sort of protection from the decay. The third one is the preservation, where I work. It was started in 1908, but institute was built in 1923. But before that, the work was started all over India. All the railway sleepers, you can see that all were treated in FRI, and the most of the world-known preservatives like copper chrome arsenate, that is askew, and copper chrome boron, which was invented. These two preservatives were invented in wood preservation branch, and till date the efficacy is, I mean, everybody is acknowledging its efficacy. So we belong to this discipline. And next one is the composite wood, which deals with the composite products like panel products and every section has a expert team of experts. And next one is the woodworking and finishing, where we develop the finishes and its correlation with the moisture content. How much finishes are required for bamboo or any wood species. So that sort of work we are working. We are basically focusing on the efficient utilization, judicious utilization of the wood and bamboo. And we conduct the forestry research and awareness programs, capacity building program. Besides that, we have a university also, that is a Forest Research Institute deemed university. And we are running different courses, and wood science and technology is one of them, post graduation courses. So we have technical manpower for that also, who are trained in the particular department. Next one, please. So as I have just shown the recent work what we are doing. So bamboo extract I have already described. We are working on in the preservation branch. We are working on the fire retardants preservative compositions. The preservative is basically for longevity of any product. But when it is combined with the fire retardants, we have to develop the protocols that how it works, so that give the protection against the biological agencies as well as the fire. So we are working on that durability assessment of the bamboo in field. It is not only the development of the preservative. Like recently, we have developed an eco-friendly preservative, which is called as a ZIBOC, and which is accepted in our Bureau of Indian Standards 401, and which is environment friendly and which is comparable with the conventional preservative SQ and CCB, which is word all over world known for its efficacy. But it is not like how you develop the things. So we go for the durability assessments of bamboo as well as for wood in field. We test the product for certain times at different locations. Like for Dehradun, it is a moderate. If you go to the Chakrata hilly side, you will have the fungus attack only. So that is a temperate zone. Whereas if you go to the arid zone, that is Jodhpur, you'll get only termites there. So combined sort of results we get. On the basis of that, we develop the preservative. So we are developing eco-friendly preservatives. We are developing the preservative plus fire retardant combinations. We are testing it, and so on. And the next branch is we are also working on the bamboo waste and development of structural panel products in the composite branch. Seasoning of bamboo I have already covered. Then the color and finishes. Next one. Next one, please. These are the mechanical tests. You can see we have a full-fledged of a mechanical branch here, where we test the all sorts of bamboo. We do the research and development programs, as well as we test these products from various agencies. Next one, please. Next, this is a plant. Previous one. This is a plant where we work. This is a wood preservation plant. We have a plant of approximately 4.5 meter dia and 12 feet have the length, and where we do the final trials for that. But before that, we have a small setup machineries where we develop the fire retardants and preservative composition. Next, please. This is how we do the testing. If you are interested to get the test only for the termites, then we perform it only for the termites. You can see that we have the termite mounds. We treat the samples along with the control. We place it in the termite mounds. After a season, we take out the things, we see the damage, and again they are reinstalled. So the 2 consecutive years we go for this test. It is performed in the wood, it is performed in the bamboo, it is performed in the ply products. So it is a well developed plan which we do here. We whenever we report any preservative or any product, it is mandatory to go through all these tests. Only then we can report this, yes, this product is working. Next, please. This is a yard test. You can just see that a certain size of the sample is embedded in the ground, and if after treatment or we take the control at different locations, and periodic inspections we conduct. And it is recommended that if the product is working for 10 years, then you can say that now this product can be recommended. So ZIBOC, we have already tested it for 12 years. So after that, it was accepted in 401 standard, and now it is going to be printed. So this is a sort of thorough examination of any preservative or any wood or any bamboo which is treated. Next one. This is a structure panel boards. We have full-fledged laboratory where we have the press, hot press. We make the products, we test it, and developmental. There are so many things are in the developmental phases, but still there are many things are ready for the field also. Next, please. We are four speakers in the session. I know that everybody will be talking about why bamboo, but I'll be talking about from forestry perspective only, from forestry point of view. We know that it has faster growth. Why? Because only the longitudinal growth is there. There is no lateral growth. If you see the tree, you will find the secondary wood and the primary wood, and the sapwood and the heartwood. Whereas in case of the bamboo, we don't have any wood. Only the longitudinal, growth is there. That is why the growth is very fast. So the advantage is that faster growth is there. In 4 years or 5 years, you can have this material, and it can be harvested annually, non-destructively. You are not going to harm. You don't have to dig out all of the material from the soil. Again, it will be through rhizomes. It will be flourishing there. It will regenerate the degraded land. It can be intercropped with the shallow-rooted crops. It helps in the soil to prevent the soil erosion, and there are so many properties are there. That is why we say that bamboo should be used and should be considered in place of the wood. Next one.
Madam, will you be able to wind up within 3 to 4 minutes?
Yeah, sure. Why not? So this is just the data which was. You can just see that the 40%, 35% goes to the pulp, whereas for non-residential and residential purpose, almost 40%. That means that we are well on the ground. That why we should justify that why we should use the bamboo, because more 40% goes for this sector. So we should again think of using this material. Next one, please. These are this is categorized on the basis of their structures. You can see that many times the people are asking for this. We have this bamboo, for which use it should be. We have a long list. I have shown one, Bashir et al. In 2011, he has categorized all sorts of bamboos for different uses. Next one, please. This is natural durability. The bamboo falls in the group 3. That is, if we, I have shown you the yard test. If we place a treated sample in the ground outside, and without treatment, if the life is less than 60 months, that means it is non-durable, and the bamboo belongs to this category. That means we don't have any option, we have to treat the bamboo. Next one. This is a hut which was made in 1955. Still it is this is a plant area where we work, and it was made in 1955. Now the 65 years has already passed. Now you can see that how much longevity is there. Otherwise, bamboo has a natural durability of 3 to 4 years only. So you can see it is in the open and it is working. Next one, please. These are the conditions which are basically responsible for the decay. Next. This is the initial. Whenever you see any sort of infestation is there, you have to remove the material from the lot, because this shows that all conditions are favorable for attack. Next. These are all sorts of molds, and what it is doing, it is just decreasing the value of the product. So we have to check it. Next. These are the termites which are and the borers and the pests, especially beetles, powder post. They are enemies of the product. Next.
Madam, you have about 1 minute.
Yeah, sure. Now go to the next one. Preservation is a process through which we impregnate the toxic material inside the wood or bamboo. Next. These are the procedures how we do the preservation. Next. This is a procedures: diffusion, round table, dipping, brushing. Next. These are the procedures which are very, very common in the field and which are very, very easy to do. Next. This is a process, butchery process. Full length bamboo, green bamboo can be treated. It has a very, very long life. Next, please. Next, please. So this is how we check, how we treat. Next. These are the type of the preservatives. Here you can see in the third water bond, SQ, CCB, CCA, ACC. These are all preservatives which are water soluble. So no liquid is required, no solvent is required. Just make the 4% solution, treat the bamboo. Next, please. This is the procedures. So because of the time constraint, I won't be going in detail. Next, please.
Madam, will you be able to summarize now?
Yeah, sure. These are the different usages. Dry bamboos, you can see in the second column, which type the preservative, what should be the concentration of the preservative, then what should be the retention. If the proper retention is here, only then it is going to be survived. Next, please. You can have the this thing, the hyperlink.
Madam, I think you'll have to summarize now within a minute. You're already
Okay, you
completed.
can you kindly show that. I'll just this you can you just go on that, just flash and just go on that. You can see that how we are making the structure, how we are making the Zafaris mesh. Next, please. Next, we have made the structure. It was made in 2008 with the Zebak preservatives. The floor. Next, go ahead. The how the mud is with the fire retardant and the preservatives. Next, please. The floor. Next one. These structures we have already shown you. The how the shed was made in 2006. Still it is there. So now you can calculate what is the economics. You have saved the material, you have saved the money, you have saved the labor for the 15 years, 10 or 12 years or 15 years. So that is the simple justification why we should preserve the wood or bamboo. Next, please. Next, just go on. These are the recent work which we have done with the in the this green skill development program. Educated crowd was there, youths were there, they were trained in all sorts of structures. All treated structures are there, and we hope that it will be there for the next 50 years. That is all. Thank you so much.
Thank you very much, madam. And as all of you must have heard, madam, it was such a lucid presentation, and the expertise of madam in the field of bamboo development was evident from her presentation. We have our second eminent speaker, Dr. Vipin Chawla. Dr. Vipin Chawla is working as a scientist E at IPIRITI, that is Indian Plywood Industries Research Institute, located in Bangalore. Dr. Chawla has been working on various aspects of sustainable byproducts of wood, and bamboo is one of the very prominent aspects of this particular research. Dr. Chawla has also been expert in fundraising and also implementing the projects on sustained basis. Today's presentation will be based on bamboo composite technology for housing structures. May I now invite Dr. Chawla to make his presentation? We have 15 minutes, sir. Thank you so much.
Please. Now, shall I start? Professor
Yes,
Sanjay Deshmukh, thank you,
please.
sir, for introducing me. And I hope I am able to listen for the participants. So, I am Dr. Vipin Chawla, scientist from Indian Plywood Industrial Research and Training Institute and heading the bamboo division also. So, can you load to my presentation? Please upload the presentation. So, as a topic is given for today's discussion is bamboo composite technology for the housing construction. The EPT has done a lot of the work in establishing a technology, especially for the bamboo composite technology, and implemented in the structures. Next, please. So, as already we have discussed a lot about that easily availability, low cost, high strength weight to ratio, capacity to absorb more energy, and it is a renewable resource. So, but it has a drawback also. It has a limited durability. So, madam already discussed about that. We have to treat it properly, and otherwise it is not lasting for more than 1 year or 2 years like that. And it has also a drawback in jointing of the structure. So, we have to develop a joints technique. So, we have developed the work in this line, and structural design data is also not that much available. So, limited structural designs is available. Please next. So advantage of structural application of the bamboo is like that it is easy to cut and required size with a simple tool. So we do not need to buy a specific heavy machines or the heavy tools to cut it. And the surface is very clean because it have a silica layer, and it is the epidermal layer is very hard to attack. So it has hard and smooth and hence less wastage. And interknots adds strength to the bamboo because the more lignin content in the joint, the interknots, high tensile strength, it has a very good tensile strength, and skill labor is not much required. Just giving a small instructions to the little instruction to the labor, they can handle easily. And now it is under the national building code also. Next please. So based on this bamboo properties, MOR and MOE, modulus of rupture and modulus of elasticity and maximum crushing stress. So bamboo can be classified into the three categories: group 1, group 2, group 3. So based on this group category, the structural engineer can decide that which part of the which type of the group of the bamboo can be used for the structural purpose. Next, please. Next. So bamboo for building structures, that affordability, bamboo foundations is very minimum required. So basically 2 feet digging is sufficient and not much width is required. The foundation is simple, not heavy reinforcement of the metal or other things required. So sustainability, environment impact is there. Bamboo is available commercially in large quantity and supply system is very good. It's a good source. But during the construction time, we have to select only the specific species of the bamboo, and that species is the Bulkova species, and before application we have to treat it, and it is the system of a traditional material, so it is not a new material, it's a very old material, but we have to use it in a better engineering way. So the result is, we can see it in the next slides. Next to the please. So for building systems, we have to treat the bamboo as much as possible with the proper retention so that it can be last lasting. And nailing is not possible in the bamboo, so we have to wire it and bolting it or make a jigs bolts and like that to make a positive connectors. And it is modular construction is like that. It's just suited to either prefabrication or fabricated to make a design, and one place we can construct the structure. So now we are going to the bamboo composite technology. We design the composites in the lab and plants, and then we can create a structures in one place and shift it to the another place. And the assembly is very easy, just simple nut and bolts and tied it and install it, like in the construction of the metro bridges and all these things. Next, please. So before starting the bamboo composite technology, it's divided into the two parts. We have to do the primary processing of the bamboo to make it usable form and cut it in the proper size to make it either slivers, strips, or in the other form. So we EPDT developed 3-4 generations of this technology. In 1985, we developed the bamboo mat-based product. It is known as the Generation 1 technology. And after that, the demand is come for the bamboo strip-based products. So after 1985, we in Kerala, we have transferred the Kerala Mat Development Corporation, Bamboo Development Corporation. We give this technology in 2001 around. It's a generation 2, and the lumber-based technology, which is now industry using, and it is very much usable products in the form of a laminated lumber, or you can say it is a heavy structural purpose can be used it. And next is the advanced bamboo purse products, which is particle board or MDF. We come to the each first, second, third, fourth in next slide. And all of these generations we have to use, we are using in the housing construction. So purpose of this bamboo composite to implement in the bamboo housing structure. Next, please. Next. So the primary processing consists of the various line of the machines. The machine is first machine is cross cutting, then second machine splitting, which split the bamboo of the required width and the thickness. And then we have to remove the epidermal layer and endodermal layer, which is not good for the bonding purpose. And next is the slivers making. Next, please. Next. So after this slivers making and all these things, it has to go to the rural livelihood program. So it can be utilized, it can generate a lot of the employment to the village area. So this mat slivers based products, EPDT developed that bamboo mat boards, bamboo mat veneer composite, bamboo mat composite, and bamboo mat screen doors, and the bamboo mat corrugated sheets, bamboo mat ridge caps, and bamboo mattress. So these all products are developed from the mats. Next, please. After this, then we realized that is mat-based products is required a lot of the manpower, so we go to the mechanized products. So that horizontal laminates and vertical laminates, they are the two products which can be used for flooring and other wall paneling purpose. The basic purpose in the both the products, bamboo mat-based products and the strip-based product, resin is common, phenolic resin. The specialty of the EPDT for developing this composite technology, we standardize the resin as per the product's requirement. So that technology is with us. Next, please. So we use this strip-based products under for construction of the theaters or the stairs purpose, or in the halls or badminton halls we can use it. Next, please. So you can see the application. So these are the application of the laminates. So it's well defined. So next product is the bamboo lumber. As we come to know that bamboo is in a structural purpose, but round shape, but it is very difficult to manage it in the strip form. So just squeeze it in the form of sugarcane like in machine and make a crush form. So first slide is showing that this is a crush part, and under the pressure and the temperature, cold press or temperature press, we can make it to lumber form. So this is just like a 6 feet by 6 feet length and 5 inch by 6 inch cross-sectional area, the lumber is producing in India in 2 or 3 companies. So that we have to treat all these things. We have to dip it in the resin, we have to press it, and then we have to cut it as per the requirement. Next, please. So these are the applications of the bamboo lumber. So almost bamboo strip based product is the second generation. Lumber is an advanced generation product. It's a highly finished product. Next. So next product, which is we can use it, minimize the wastage, is the particle board and MDF. So we just crush it and then pass it to the press. The press can convert it to the board. So this is also a good product, but due to the high investment, not a single industry in India. So it is a big project for us, and it required a lot of the bamboo for processing it. Next. So we in EPDT we have developed a TRADA technology. EPDT TRADA technology is just to define it how to use the bamboo and can make it possible for the engineered way wall structures and all these things. This already Sadhana madam has explained, so I am not going to in depth. Next, please. So before putting the structures, we have to develop the foundations. So hardly 400 mm, 600 mm structures, we have to put a column. So this is a treated bamboo column. So before selecting that, we have to specify for the diameter of the bamboo species. So 2.5 to 4 inch is sufficient for this, and wall thickness we need half inch more. That is sufficient. So we can make the structures with a gap of columns 1 feet, 1 meter by 1 meter. Next, please. So while erecting these columns, we have to treat the ground also. Otherwise, termite or borers attack will start from this. So we can use a suitable chemicals, and the chemicals is having the good penetration effect that we have to take care while treatment. So the treated bamboo columns comes of 80 to 100 mm diameter and wall thickness of 10 to 12 mm. So selection of the bamboo is a vital parameter for constructing the house. If your bamboo is not properly treated and not properly selected, the building may collapse. So we have to give all these parameters importance to the parameters. Next, please.
So you have about 5 minutes.
It's okay. So before that plinth and flooring, that we have to use the bamboo strips only. So normally the wall thickness may be the 9 inch to 12 inch, but in the case of bamboo composite houses, the wall is about 5 inch, 3 inch. So in the reinforcement of the strips with the chicken mesh and the same cement mortar ratio, we will use it. Next, please. So this is the structure, how we use it for the calling purpose in EPDT. And we have established this house all over India, maximum places. Next, please, we come to know. So we use the corrugated sheet. So we utilize the corrugated sheet on the structure purposes. So we use it and we make it possible how to clamp it, J-bolt fixing and all these things. So I will not go details. Next, please. So this is the doors and windows. So before constructing, we have to make a suitable plan for this. Next, please. So this is from last 20 years, the building is as good erected and nothing happened, and it's not much maintenance is required. The only thing we have to take care of roofing purpose only. The wall and all these things which you have seen it, the post, it's inside. The reinforcement is the bamboo. If you can see the rod left right hand side, that is a 1 meter by 6 feet height is that in the left hand side corner. Next, please. So these are the various constructions we have developed in the various places. So these you can see it. Next, please. So this is a prefab house. So in this house, we do not use a cement and use the structure constructed in some other place and install it at the one place at the site only. So these structures, first we put it with the wooden structure, and second we create it on the concrete and the iron structure. Next, please. This is the blueprint of the drawing of this layout of the house. Next, please. So we basically use the bamboo mat board for the prefab house, double walling system. It has good high rigidity compared to plywood. It has good flexibility and can be used for gadgets and all these things, low beams. And it has double walling system give a better acoustic property and better thermal properties. It gives good importance to the building. Next. And these all are the IS specification standards material. So this is the phase of the prefabricated single wall houses constructed at the Gujarat Forest Department. We structured with our scientist team. So we have a full team for structural purposes. We have a 3-4 teams. One is a testing team, one is the engineer teams for the site work, and one is a composite development team at the on the other side. Next, please. So these are the phases where how we generate the programs. So we have structured the material. So this picture itself define it that how we develop it. Next, please. So see that how nicely use the not bamboo with the material of the metal only. So 100% bamboo is not possible. We have to use a other material also. Next, please. So recently, 2 years before, we have developed a structure with the Telangana Forest Division, and that house is used for this recreation of this multinational companies in the botanical garden. Next, please, in Telangana. So these structures we have developed in the outhouse extension work as in the Delhi place. Next, please. This is a prefab structure totally. So this is a different places in India we developed it. So this is the demo houses to give the information to the public, understand it. Basically, these structures, why we develop it, to tell that these structures can be erected for last 50 years, can be possible to life it. Next, please. So testing part, already madam shown that before constructing anything, we have to test it as per the building standard codes. Next, please. So it is a good fire retardant property, also having the roof pressing test we have done, flame test we have done, and the load bearing test we have done. And we have done the shock resistance test because in the earthquakes, the normal buildings can bear a cracks and all these things and may collapse. But this the bamboo has a good property. It once it absorbed, once the earthquake shocks comes, it take it and after some time we regain the shapes and it will not give a negative effect on the buildings. And this passed to the zone 5 reactor skill test methods. And we did it and we added it in the national building code also. So this is the beauty of the bamboo material. So we are using a excellent material without much knowledge, without much scientific work, but it is one of the best material, science material to use it for the construction purpose or in other interior applications. Next, please. So these all we are developing this bamboo roofing material. So this is the how we bamboo corrugated sheet we develop. It is eco-friendly, highly resistant, low weight, low thermal conductivity, aesthetic. So as compared to asbestos sheets or the iron sheets, the galvanized iron sheets, this material is far better. We need a bamboo mats to develop this technology. So it is also a good scope for the green structures, green building material. Next, please. So in this case, we develop the techno-economic viability, the conventional construction technology, along with the spiraling cost of traditional building materials, make house unaffordable at distance for an average income of 8%. Bamboo wall-based houses are energy efficient and save 60% of the cost of masonry construction. It is not a costly construction, but if you add more high-end uses application, it's person to person vary the construction. So if you add more, then its cost is increased. So again, I'm saying that it is as compared to other structures, it is a cheaper, but it is not without in technology. It is not cheap. We have to use technology, otherwise it is harmful. It is maybe after 2 years, 3 years, building may be collapsed if you do not use the proper technology. Next, please.
Sir, can you conclude within a minute?
My slide is not conclusion. Technology evolved can be effectively adopted for affordable housing. Technology can be easily adopted by skilled masons, carpenters, but orientation training program is must required. Based on the work done so far, the technology can be adopted in areas with normal wind pressure of 100 kg per meter square, maximum height for limited up to the 2.4 meters when used with a bamboo of 80 to 100 diameter with 12 wall thickness, half-inch thickness with a 1 meter center to center structure. My suggestion is that without technology, should not go blindly to the bamboo houses. Use the proper instructions, guidance, and with minimum 10 people, then use it. Next, please. So if anything you need for the structures or the composite technology, we have full set of the teams with the various departments working in this line. And we are on the path of that, how to make a high-rise building with the bamboo structure. It is going on. So in the next webinar, you will see that how to come to the future research in this area. Thank you very much to the listener.
Thank you very much, Dr. Saab. And I'm sure our participants who have crossed the number of 500, which is very encouraging, must have really got enlightened with this excellent presentation. Now we have the third eminent speaker and one of the highly professional bamboo experts in our country and also in the world, Shri Sanjeev Karpe. Shri Karpe is basically an electrical engineer by training, and after serving as a grade A entrepreneur associated with the Indian Railways, he switched over to his commitment of application of his work for societal development. By setting up an NGO, of which I was also fortunate to be a part, which works now on bamboo and related aspects, including medicinal plants for community development, Dr. Karpe has come a long way in the last 20 years in setting up not only enterprises for himself, but also for setting up enterprises for various state and central government projects. He represents a high level committee of bamboo mission as well as the National Biodiversity Authority of Ministry of Environment and Forests, and he has demonstrated through his experience utilization of indigenous bamboo for construction as well as for low cost housing as well as various applications. Now I invite Shri Sanjeev Karpe for making a presentation as to how the bamboo from local areas can be utilized for various interventions for livelihood security as well as professionally managed large scale enterprises. Shri Sanjeev Karpe.
Thank you very much, Professor Deshmukh. I am here today to talk about prefabricated bamboo structures. We are working in bamboo for last more than 16 years in Sindhu district of Maharashtra. Everybody knows that bamboo is one of the most sustainable raw material, fastest replenishing woody grass, which has a fantastic capacity to sequester carbon dioxide up to even 200 tons of carbon dioxide per hectare per year. This emits a lot of oxygen during its production, and this is a material which can provide employment opportunity to a lot of people. If you see the global scenario, India is the second largest bamboo producing country in the world. But if you see the international trade of a bamboo product, first top 10 list government, India is not there. A small country like Thailand, Singapore, Indonesia is there, India is not there. India is there in a top importing bamboo product importing country. So in 2004, we decided that we will set up an organization and start working in bamboo. First thing which we did is setting up a pressure treatment plant to increase the durability of bamboo. Every time you may not get a straight bamboo pole, so you need to have a facility to straighten the bamboo. We have trained our local artisan to do straightening using this very, very traditional method. And you can, if you use a high skilled labor, you can absolutely straighten bamboo like a pipe. Bamboo can be bent very uniformly just like a pipe. And once you have treated and graded raw material, then making any product is very easy. We started prefabricating structural component. We started with the very small cottage type of a construction first, where the column trusses are prefabricated in a unit. So for trusses, we initially started using a gusset plate made of a bamboo mat board, and slowly eliminating even a gusset plate and using complete round bamboo for making trusses. We started doing cottages in different places, got a good response. We always took care that the product should look good aesthetically, it should be beautiful, as well as it should be durable. We got excellent response from our customer, and which gives us a motivation to do bigger work. So we started doing a bigger structures. So prefabrication of component, again we started doing it in the factory, and for the bigger components also. For a bigger structures, you need a stability certificate from a structural engineer, and because bamboo is a bioresource, you may not get a uniform uniformity in the raw material. So initially we started with the load testing methods. Most of the load testing happened either on a site or in our factory. Once the components are ready, they are packed and sent to bigger trailers on site, and we started prefabricating that components on site. So we got a chance to construct a really big structure in Hyderabad for a builder Organo in Aziz Nagar. This is a 10,800 square feet of a structure with a 64 feet of a span. And this structure gave us a confidence that yes, in India we can also do a good bamboo structure, just like what we see abroad. And after that, we got a opportunity to work for government of Maharashtra. This is a research institute belonging to forest department. And to tackle the bigger project, we don't have the required strength. So we tie up with a company called Jans Bamboo, and with that effort, we could able to bring in best of the management, best of the practices, and then we started using first time Bambusa Balkova as a raw material for a structural member. So typically 100 mm of a dia, and we started doing construction with Balkova. Because Balkova is more in a dia, so bending, there is a limitation of bending. So we restricted to not much more bending, but reasonable bending with Balkova. And we did this type of a construction using mainly Balkova as a raw material with around 100 mm dia, 80 to 100 mm dia material. Then we shifted to a smaller dia bamboo called Dendrocamelus stocksy, which is locally available in Sindhu district, with 40 to 50 mm dia. And we thought that we should able to make even bigger structure with the smaller dia bamboo. So we did this also using 50 mm dia bamboo, got excellent response for doing a bigger structure, larger span structure with the smaller diameter bamboo also. And after successful attempt of this stocksy, then we started using stocksy for the bend components, and bending was much more than what we used to do. We started doing that in a structure, and this particular work is done again in Chandrapur by Jans Bamboo. And this is the combination of a Balkova and stocksy. So all the bend member, what you see here is stocksy, which is 50 mm dia bamboo, and all the straight members are a Balkova, which is 100 mm bamboo. So this combination also worked well. Only issue which we faced for this particular structure, because this was around 1 lakh square feet of a total area covered in that campus only, around 11 buildings. We thought that now the prefabrication, we need to do more of a prefabrication and less of the work in a factory. Then the real question was whether we are globally competitive, or pricing is globally competitive or not. So we decided that we'll go outside India and bid for the work, so that it will give us idea whether our rates are globally competitive or not. Water of Austria, which is one of the high-end brand of Hilton, was doing high-end resort in Maldives at Itapushi. They had a complete restaurant in bamboo. So we bid for that. We got the work. Then we started doing all the components in our factory in Kudal. And these components are first prototype in Kudal, and then packed and sent to site. And we could able to do this work in Maldives and this could able to prove that yes, our pricing, our quality is globally competitive. And I'm happy to tell you that this particular restaurant has been rated as world's top best 16 waterfront restaurant by CNN UK. And this is a clear cut proof that yes, India can do it. This is the Indian bamboo, Indian manpower going abroad and competing with the Chinese and Vietnamese player, and coming out with the excellent results. But the only limitation in this work was it is a basically craft work. Doing this work by a very high skilled artisan, most of the assembling work needs a lot of time. So we thought that now, to make this replicable, you need to take one more step, and we decided that we will have now pre-engineered bamboo building, just like any metal pre-engineered building. We got the opportunity to work with Rajarajeshwari Temple Trust in Hulkoti near Gadak in Karnataka. This is a marriage hall of a 500 people sitting capacity. So we made first component in our factory, and all the components are then prefabricated in our factory at Kudal, and this is the actual erection where you'll see that the bamboo, which is a non-uniform material, which is tapering material, but the accuracy achieved by our artisan is absolutely in So it is as accurate as any other metal building, metal prefabricated building, and that is the achievement which we could able to get because of all our highly trained artisans, because of scientific approach which Jazz could able to bring in, and the whole scenario, whole the game has changed. No, now the work, whatever we work, bamboo work we are doing, it can compete with any other raw material. It can compete with any player globally. We are getting continuous repeat order from our clients and other clients from that country. So we have done work in Uganda also, in Maldives also, and it shows that yes, India can do it, and we have a required capability to uh, show that yes, we also can do good work with bamboo. Thank you very much for giving me this opportunity.
Inspiring presentation, Karpeji, and I'm sure our audience must have got thrilled to look at the diversity of structures, some of the most exquisite structures, as well as the implementation of projects right from the grassroots level up to an international level with highly competitive standards as well as prizes. Congratulations for this wonderful presentation. Now I move on to the last presentation by our expert in the field of bamboo based construction material, particularly the structural material on sustainable basis. We have Dr. Supratik Gupta, a professional from IIT Delhi and a doctorate from Nagoya University in Japan. For the last 10 years, he has been associated with IIT Delhi and has made a mark, particularly in pioneering research in bamboo based construction material. He has come out with a very refined product which is called bamboo based concrete, which is named as Bamcrete. And that material is used not only for soft columns or even larger structures in bamboo based construction. Dr. Gupta brings along with him a team of experts, and with IIT Delhi in the forefront of this particular effort, the work has acclaimed global appreciation. I would like to invite Dr. Gupta for his presentation, which will be in two parts. He will be not only touching upon the technical aspect of the presentation, but also will touch upon the policy aspects of overall gamut of this topic of the webinar. Dr. Gupta.
Thank you very much. I would like to thank all the participants, Deshmukh ji, Shadana ji, Chawla ji, and Karpe ji. I'm really honored and to see the great work you have been doing. I'm also a small partner in the bamboo industry. I've been working in the bamboo for last 10 years. I am from Assam. You can see my presentation that time. It is basically a technology which I lived in my own house about the Assam type house that I had worked on. It does not look like bamboo, but it utilizes a lot of bamboo. Next. It is based on one of my students' PhD work called Ashish Kumar Das. You can see the house, first two pictures, they are basically my own house where I brought up in childhood. The bottom part is brick work and the top work is the bamboo wall. And you can see how the bamboo wall is made. It is made with gaps between the bamboos, and the cement across the bamboo gets connected to each other and creates a very, very strong material. It's something like ferro cement, but I like to call it independent term called bamboo wall. Next. The properties of bamboo, I can skip. Next. 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 So you can see in past people have made lot of different type of walls, and most of the time they have not plastered it because they want the beauty of the bamboo. In that case, you have to plaster it. You have to paint it with a painting material, or you have to have a protection mechanism. On the other hand, next. This is also different type of bamboo without this thing. Next. 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 So you can see this is the first time application where people try to protect the bamboo with mud plaster. And it was one of the most prominent construction technology across the world. Next. Same thing. Next. Next. You can see this is the impetus structure. Between the gaps, the concrete binds together. But if you have no gaps between the bamboo, the bottom one, it will not get connected and it will not last. So we need to have gaps between the bamboo. Next. So these are the most beautiful houses of Northeast, and it is there for last 100 years. I am very sad that this technology is dying, but it is one of the technology that can make the houses very easily, because cement mortar is very cheap, and bamboo is also available, and we can have walls of the thickness of 2-3 centimeters. Next. This is how it shows that between the wooden frames we had the bamboo walls. This is my own house. Next. Next. These are the, in the presentation, the bamboo spaces and all the. Next. 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 Okay. Here previous slide. I want to mention that we are not so lucky like the central equatorial belt where they get really big size bamboos, or like China, which has very straight bamboo. But the material is still there is abundance, and I'm sure all the participants that has presented, they have utilized this material in a very good way, and Assam type house is one of such applicants. I will be talking of the policy matters in my next presentation. Next. Next. Next, let us skip that because a lot of people have talked. Next. So here I have already talked about the construction policy, how the construction is done. Next, let's go. You can see this house after 40 years was dismantled because my parents want to make a multi-storied building out there, and it was a very sad moment. But so there were the bricks in the bottom had undergone deterioration, but the top part after 40 years had seen no deterioration. Next. So this is the wall, and you can see after 40 years when we opened the wall, the bamboo was not even treated. It was a very poor quality bamboo, yet after 40 years there was no degradation inside the bamboo. So it also means that though we have very, very strong methods of protection of bamboo, inside the concrete, bamboo itself is well protected because it disconnects the food supply or the supply of supply chain for the sustenance of the attack. Next. Next. So we did a lot of scientific tests and it showed excellent results. Those things are, I think, no need to explain now. Let's go ahead. Next. So we tried that if we can replace wood with metallic joints, and it turned out to be very good. We could say the single U and the W. In the W, I tried to make double panel because in the double panel, it became more resistant to thermal and soundproof this thing. And at present, I want to tell everyone that we are even testing these panels against blast and bullet resistance. One of my PhD students is now working on blast and bullet resistance of this bamcrete elements. Next. So these are, you can see how panels are made. Small panels can be made, prefabricated and taken to site, and the plastering can be done on the site. So it is very easy to construct. Next. You can see you don't require metallic connection. You can do connections with bamboo also. In between, in place of wood, you can connect with bamboo also. Next. So you can see that we tried different type of joints. We used the heated technique. We used bamboo in the corner. So different type of joints were used. Next. Next. We keep on going. Next. So we, in place of the mortar mix, which people use inside, because masons generally don't bother about how much water they are using, because they don't use chemical plasticizers to gain the strength. So even in the housing sectors, my father is a contractor. I told him, why don't you use plasticizer? Because by using small amount of plasticizer, you can increase the strength significantly. So I suggest this industry that take little care and used organized mortar rather than using unorganized matter. Thereby, it can increase the strength manyfold. Next. So we can do the plastering by hand or by spray technique. Next. 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 So you can see the pictures. Next. So this is a room that we made. We made columns like this. Next. Next. So we made the walls of the room in this way. Next. So you can see how the construction was doing. We had put even because you can see that we could put the wiring inside the double panel also. So we could solve the concealed wiring problem also. Next. You can see the different corners. Next. 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 And it had excellent strength properties because we had used a high strength mortar. Next. Next. You can see this is how the room looked before plastering, the previous slide. This is in the top middle, you can see that this is our room, how it looked bare before the plastering. Next. And see the bottom, you can see after plastering. Next. Next. So this is the construction of the first house. Does it have a video? Can you play the video? No, not this one. Next. Video is in the next slide. Okay, you can see how the plastering was done, how the foundation was done. Obviously, if you do good plaster foundation, the material will be protected because cement always protects the bamboo in the foundation much better than any other material. Next. You can see how the construction was done. Next. Next. Now please start the video. keep jumping and showing in fast way. हाँ, आप आगे बढ़ते जाइए, थोड़ा थोड़ा आगे बढ़ते जाइए. हाँ, पूरा दिखाने का जरूरत नहीं है, जंप करते करते दिखाते जाइए. आगे बढ़ा दीजिए. अरे नहीं, टाइम फ्रेम आगे बढ़ा दीजिए. वीडियो चला के जंप करके करके दिखा दीजिए. Okay, let's skip next. So I basically wanted to say in that previous video that when we broke it, when almost all the columns were broken, the wall was still taking the load and the wall almost acted like a load bearing wall. So next, let's go ahead. Let's finish the presentation. We just wait here. We did a lot of different type of energy absorption experiments in this PhD work, and it turned out that this bamboo wall, it had a very excellent energy absorption capacity, and it also had a very good thermal and heat soundproof characteristics. And we are proposing to the military that in the border areas they can use this material as a bullet and blast resistance wall also. Next. So thank you. Let's stop. Let's start the other presentation where I will explain to you the purpose of having this group. We have been working in this bamboo industry for last 10 years. As you can all understand, great work is being done on FRI. Great work is done by IPRITI. Great work is done by KONBAC. We are also doing quite a amount of good work, but still, our industry is not united. So this we had a very strong discussion with Karpeji, and yes. So bamboo as a structural material, the challenges and the path ahead. Next slide. Next. So we have already seen bamboo can be used, and bamboo in India is mostly not like in China. It is like bush like this that we grow. Next. Lot of beautiful structures are being built by abroad, and we are not far behind. The reason behind why they are able to do it and we are not able to do it is because of the quality of bamboo is very different from there and us. But just because our bamboo is not so good does not mean we cannot do good structures. So next slide. See, this is the structure by KONBAC, and not just this, KONBAC structures, you have already seen majestic structures they have built. But unfortunately, please understand, next. So unfortunately, we are still lagging behind, and it is one of the few companies that are making such structures. It is not becoming a phenomenon. One of the most important thing that happened in last few years, and that was also contribution of Karpeji and their group, they convinced the Government of India to declare the forest made in the farmland, not in the forest, as grass and can be cut and transported. Yet, various parts of the country are still facing problems, and because there is no clarity about the implementation process. So I think Government of India, with our help, also should implement this in a transparent way. Next slide. Yeah, next slide. Okay, no. So this is what is the purpose of forming this group. The biggest problem in the bamboo industry is the quality of bamboo, because it's 1 year bamboo or a 3 year bamboo does not look different. So we need to ensure that a construction company, when it starts a construction, he gets the supply of the bamboo. On the other end, the farmer also needs guarantee. If I hold the bamboo, I must get my price. So in this group, I had been long talking about that let us create a system in which the farmers can be monitored and the buyers can see their bamboo growing online. Because if a farmer has planted a bamboo, say 50 comes, or maybe the number of bushes can be monitored and numbered and even marked, So the how many stocks they have or how many they have sold can be monitored, and I propose a system in which we create a system where the supply chain is well maintained. And then we must establish bamboo testing facility which garners the confidence of the users. Many times the quality of the bamboo is itself a question. You must unite all the people working in the bamboo. So in this webinar, basically what was an attempt? At present you saw four presentations, but we could not give full justice to our presentations. So in future, you will hear single presentations of 40 hours, and all of you will be able to understand that bamboo itself is a material to think about. And we will not just take presentations from experts, we will also take presentations from people working in the site. We will also try to have workshops online, and this will, I hope, this will become a place to unite. And of course, everybody will join. We will create newsletters. We will conduct regular webinars. And I hope with this, our group, everybody will be benefited. I think Professor Deshmukh will also explain that we want a feedback. All of you who have registered, we will ask your feedback about how we can take this forum in a strong way. Thank you very much.
Thank you, Dr. Supratik Gupta. And I'm sure all the participants must have got enlightened, not only by the presentation that he has made, very lucid presentation, and he has shown with the examples of various structural changes that have been brought about by his research, and particularly the bamboo-based concrete, the BAMCrete, how the technology is utilized. I'm sure the structures shown by Karpeji at international level and the concern that has been expressed by Dr. Gupta, they can be matched, and probably a global leadership can soon be seen in terms of Indian contribution. Dear participants, the number has been increasing with respect to your viewership. We have received at least 100 questions from all of you since yesterday, right from the registration that you have done. But today, with the paucity of time, we will be able to take only 2 questions per expert. And I would like to also mention here that the answers of all the questions that have been asked by all of you, we will prepare a summary and answer each and every question, and would be able to share that with the help of a link, as well as send you individually by email the answers of all those questions. As Dr. Supratik has mentioned, we had a lot of deliberation before launching this first webinar with the help of IIT Delhi as well as KONBAC. But a lot of thinking process is been going on for the last 1 decade or so, because all the experts are working together for several years, and this is the culmination of those ideas. The main idea is that to create a new platform which will complement and supplement the work at national and global level, which is happening already. And we will be able to add something which will be different and which will bring together people from various walks of life, local NGOs, the government agencies, the policy makers, as well as the farmers will commonly share this platform and will be able to contribute meaningfully. I would like to now invite individual speakers right from the chronological order of their presentation. And the first speaker was Dr. Mrs. Tripathi, whom I would like to ask 2 questions that will be followed by the second speaker, and I will like to have 2 questions. Now, I would like to read those questions for the benefit of the speakers as well as Madam. Madam Shri E.M. Muralidharan has asked you the first question, and the question is, how can the waste from chemical preservation treatment plants be disposed of properly? The question is, how far or how can the waste from chemical preservation treatment plant can be disposed of properly? And the second question is by Shri Muhammad Gulab Sheikh, and he wants to ask a question which is, amongst methods adopted for treatment of bamboo, which one is most harmful to the environment? I repeat again, amongst methods adopted for treatment of bamboo, which is most harmful for environment? Over to you, madam.
Yeah, the first question is how can the waste from chemical preparation, preservation and treatment plant be disposed of properly? So, in this regard, I would like to just suggest that there is no need to dispose of the material, the preservative. We have to recalculate the concentration as well as the composition of the leftover after preservation is done. After that, you can remake the solution. So there is nothing like to dispose of these preservatives which are being used for the treatment. And some in the live chat, some viewer has also asked to speak in Hindi. तो मैं ये बताना चाहूंगी कि आपको प्रेजर्वेटिव को डिस्पोज ऑफ करने की जरूरत नहीं है। आपका जब एक बार ट्रीटमेंट हो गया तो यू हैव टू रिकैलकुलेट द कंसंट्रेशन। अगर वो 2% मान लीजिए आपने 4% में किया, वो 2% आ गया, तो उसको रिकैलकुलेट करके वापस उसमें उसके कंपोनेंट्स को एनालाइज करके कि कौन सा कम है, उसी रेशियो में उसको डालकर रीमेक कर लें। कभी भी प्रेजर्वेटिव को हम डिस्पोज ऑफ नहीं करते हैं। तो दिस इज द आंसर ऑफ द फर्स्ट क्वेश्चन। द सेकंड इज अमंग मेथड्स अडॉप्टेड फॉर ट्रीटमेंट ऑफ बैम्बू which one is most harmful to the environment? इस बारे में मैं थोड़ा बताना चाहूंगी कि there is a myth that जो कन्वेंशनल प्रिजर्वेटिव है लाइक CCA एंड CCB, इसमें जो आर्सेनिक है कॉपर क्रोम आर्सेनेट में, वो टॉक्सिक है एज उसका जो भी केमिकल बिहेवियर है, और दैट इज ट्रू आल्सो। बट जब हम कहते हैं कन्वेंशनल प्रिजर्वेटिव्स, ये कन्वेंशनल प्रिजर्वेटिव फिक्स टाइप के प्रिजर्वेटिव्स हैं जो कि पूरा वेल इस्टेब्लिश फैक्ट है। 1939 में जब इसमें पेटेंट फाइल हुआ और पेटेंट एक्सेप्ट हुआ, उसके बाद से बहुत थॉरो स्टडी करी गई जिसमें पाया गया 99.9% इसका फिक्सेशन है। एक बार आपने ट्रीटमेंट कर दिया, मटेरियल में फिक्स हो गया, तो एनवायरमेंटल हैजार्ड रह ही नहीं गया। तो मेरा ये कहना है कि इसलिए लीचेबल और नॉन लीचेबल दो टाइप के प्रिजर्वेटिव्स हम यूज करते हैं। टाइम कम था इसलिए मैं आपको ज्यादा डिटेल में नहीं बता पाई, बट मेरा एड्रेस इज देयर, आप चाहेंगे तो मैं जरूर बताऊंगी। सो दैट्स ऑल, थैंक यू।
Thank you very much, madam. And I would like to request now our second speaker, Dr. Chawla, to answer the following two questions, which I would like to read out. Shri Muralidharan has asked a second question again to Dr. Chawla, and he says and asks, would bamboo scrimber to be the product that the construction industry would use to replace a variety of alternate materials due to multiple advantages, or are there disadvantages of it? The question is, would bamboo scrimber be the product that the construction industry will use to replace a variety of alternate materials due to multiple advantages, or there are disadvantages also? And the second question is by Shri Anil Kumar. He is asking, how do we conduct the life cycle analysis of fabricated bamboo structures? How do we conduct the life cycle analysis of bamboo prefabricated structures? Dr. Chawla, please.
Yes, sir. The question is very much pertinent to the bamboo lumbers related to the construction industries. इसमें मैं हिंदी में बताना चाहूंगा कि जो बैम्बू लंबर के साथ कंस्ट्रक्शन इंडस्ट्री में इसको डायरेक्टली यूज कर सकते हैं, और इसका स्ट्रेंथ प्रॉपर्टी मैच करता है टिम्बर से, और टिम्बर की प्रॉपर्टी के लिए जो स्ट्रक्चरल कोड दिए गए हैं उसको मैच किया है। द प्रॉब्लम इज दैट कि वी डू नॉट हैव द सफिशिएंट लेंथ ऑफ द बैम्बू लंबर। द हार्डली द इंडस्ट्री इज प्रोड्यूसिंग 6 feet or 6.5 feet. In case of somebody wants to use it for higher structures, they has to go finger jointing techniques. इपिटिन ऑलरेडी बनाया है, बट अभी तक किसी ने फिंगर जॉइंटिंग टेक्निक को यूज नहीं किया है। हमें 90% ऑफ द फिंगर जॉइंटिंग टेक्निक्स में स्ट्रेंथ मिल जाता है जो कि नॉर्म्स को फुलफिल करता है, मैकेनिकल प्रॉपर्टीज को। तो इसमें मैं कहना चाहूंगा कि 100% यूरोपियन कंट्रीज क्रॉस लैमिनेटेड टिम्बर को जो स्ट्रक्चरल बनाने में यूज करती हैं, ऐसे ही बैम्बू लंबर को भी यूज किया जा सकता है, और लोग कर रहे हैं बैम्बू लंबर्स को यूरोप में, और उसके स्ट्रक्चर्स बनाए जा रहे हैं इको फ्रेंडली। जर्मनी में ऑलरेडी इसके ऊपर काफी काम हुआ है, हाउसेस फ्रॉम द बैम्बू लंबर। आपका दूसरा क्वेश्चन है लाइफ साइकिल एनालिसिस ऑफ फैब्रिकेटेड बैम्बू स्ट्रक्चर्स। इसमें मैं आपको बताना चाहूंगा कि हमारे कलीग साइंटिस्ट ने इसमें रिसर्च किया है और एक रिपोर्ट सबमिट की है BMTPC को। उन्होंने लाइफ साइकिल एनालिसिस ऑफ फैब्रिकेटेड स्ट्रक्चर्स ऑफ स्टडी किया है, उसको कोड किया है, डाला गया है, और मैं इसके ऊपर ज्यादा हाईलाइट नहीं कर सकता क्योंकि हमने रिपोर्ट BMTPC पे सबमिट की है, बट हमने काम किया है इसके ऊपर। ये मेरा सबमिशन है। दैट्स ऑल, थैंक यू।
Thank you very much, sir, for your wonderful and lucid answer. And I would like to now move on to Shri Sanjeev Karpeji. And the questions which have been asked, I will take only two questions. The first question to Shri Karpeji is that as a successful bamboo entrepreneur, which are the species you would like to choose to focus for increasing plantation acreage so that more industries can sustain? The question has been asked is repeated again. As a successful bamboo entrepreneur, which are the species you would choose to focus for increasing plantation acreage so that more industries are sustained? And the second question is, how do we prevent the increase of deflection of bamboo beams, that is flexure numbers, as time passes? I repeat again, how do we prevent the increase of deflection of bamboo beams, that is flexure members, as time passes and over seasonal cycle? This question has been asked by Miss Shrutika. Shri Karpe sir.
थैंक यू प्रोफेसर देशमुख। मैं ये सवाल के जवाब हिंदी में देना चाहूँगा क्योंकि बहुत सारे लोग हिंदी की मांग कर रहे हैं। जब स्पीशीज़ की बात होती है, हम कौन से रीजन में उसको ग्रो करना चाहते हैं, ये बहुत इम्पोर्टेंट है। भारत सरकार ने 16 स्पीशीज़ को स्पीशीज़ ऑफ कमर्शियल इम्पोर्टेंस घोषित किया है और उस 16 में से कोई एक स्पीशीज़ हो तो कोई प्रॉब्लम नहीं है। लेकिन स्पीशीज़ ग्रो करते समय फार्मर ने कौन से क्लाइमेटिक कंडीशन में कौन सा स्पीशीज़ सूटेबल है, ये भी देखना बहुत ज़रूरी है। हम लोग कंस्ट्रक्शन के लिए डेंड्रोकमनस स्टॉक्सी, टुल्डा और बाम्बूसा बल्कोआ, ये 3 स्पीशीज़ को रिकमेंड करते हैं। ये 3 स्पीशीज़ अलग अलग एटमॉस्फेरिक कंडीशन में अलग अलग रीजन में होते हैं, लेकिन फिर भी मैं एक बार कहना चाहूँगा कि कौन सा स्पीशीज़ कहाँ ग्रो करना है, इसके लिए फार्मर को एटमॉस्फेरिक कंडीशन के हिसाब से करना पड़ेगा। आजकल बहुत सारे वेबिनार केवल बाम्बू फार्मिंग ये सब्जेक्ट पे हो रहे हैं। मैं आपसे विनती करूँगा कि ये इस टाइप के वेबिनार आप अटेंड कीजिए। ये पर्टिकुलर वेबिनार ये मोस्टली रिसर्च एंड इनोवेशन ऑन बाम्बू कंस्ट्रक्शन सेक्टर के ऊपर था, इसलिए इस सवाल के जवाब में ज़्यादा विस्तार से यह बात नहीं की जा सकती है। दूसरा, श्रुतिका जी का जो सवाल है, श्रुतिका जी आपने बहुत ही रिलेवेंट सवाल पूछा है। आप जिसकी बात कर रहे हैं वो क्रीप फेनोमेना है, और इस क्रीप फेनोमेना में ओवर द टाइम डिफ्लेक्शन तो ज़रूर होगा, बाम्बू में तो होता ही है। उस पर और ज़्यादा रिसर्च होने की ज़रूरत है। उस पर बहुत सारे लोग ऑलरेडी काम कर रहे हैं। फिलहाल अभी डिज़ाइन करते समय हम इसका ख्याल रहते हैं कि बाम्बू को फ्लेक्चरल में हमको नहीं यूज़ करना है, और हम अगर फ्लेक्चर में यूज़ करते हैं तो वो डिफ्लेक्ट होगा ऐसा मान के उसको वो ऐसे ही जगह पे यूज़ करना पड़ेगा जहाँ ओवर पीरियड उसमें थोड़ा डिफ्लेक्शन आना संभव है, और उसी हिसाब से काम करना पड़ेगा। धन्यवाद।
Thank you, Karpeji. And I would like to move on to the last speaker, though the time is another 7 minutes before we conclude. I would like to request Gupta sir to be brief, because there are 3 questions instead of 2 which I would like to ask him. The first question is, can bamboo be used as ferrocement works as a frame enforcement? That is question 1. Can bamboo be used in ferrocement works as frame reinforcement? Question number 2 is, how beneficial would be the light sanding of bamboo skin on bonding with concrete, or would you not bother at all? The question is, how beneficial would be the light sanding of bamboo skin on bonding with concrete, or would you not bother at all? The policy-based question is for everybody, but probably Dr. Gupta can answer as a concluding speaker. Why bamboo is not a very popular material for construction industry? That is the basic question. Why bamboo is not a popular material for construction industry? Dr. Gupta.
Okay. Okay, first let us talk about the ferrocement. In fact, if you take the Bamcrete wall component, it is one type of ferrocement bonding only. The Ipriti also has come up with similar one where they have put wire mesh, chicken wire mesh. So basically, you have to create a mesh, and both sides the cement plaster can hold it, and it can form an excellent material. So I really feel the word ferrocement is, we use the word as bamcrete element. So connecting the bamboo in this case is done where the cement holds it from all sides through the gaps between the bamboo. The second question is basically about same question that was asked to Karpeji. You are talking of connecting the bamboo and the bond that is applicable for flexural member. So technically speaking, I disagree that we should make beams out of bamboo, because the creep properties of bamboo is very dangerous. Whereas if you want to use bamboo beams inside foundation where the deflection is automatically not there, then it is a fantastic material. But if you are using a material like in the top, you must use it in a way that trees are formed, in which the umbrella is formed. So if you see the most of the structures where the bamboo is used, it is most used like structure like the truss element, or even sometimes their bamboos are curved in the curved manner where the bamboos tapering sections has been used everywhere in the world. Now coming to the third question, and that is the purpose of this webinar and the creation of the line. I really believe that every material requires hundreds of years of research to be implemented. I'll tell you a small story about pre-stressed concrete. In pre-stressed concrete, it was started by Fresnay in Europe, in France, where he was allowed to make pre-stressed concrete members with steel. First, he used the normal steel, and it broke again and again. And his people had trust in him. Then he came to a conclusion: we require high-strength steel and high-strength concrete for establishing pre-stressed concrete members. And today, after almost 100 years, pre-stressed concrete members are making concrete structures more popular even compared to steel structures in making bridges. So similarly, it is very important that we create forums for different groups, and maybe our webinar group can become the pioneer bonding material, and we can create, we want to basically create the groups, like somebody working on preservatives, somebody working on structures. So all the structures that KONBAC is making, each of the structures is worth a PhD. But unfortunately, he doesn't have time to do it. So by creating an awareness, by creating a mutual support system, and when we become a big mass, the government will be interested to support us, because they can see that we are not a powerless group. At present, most of the groups that are working individually. Nobody bothers about them. When IPRIT is submitting to BMTPC, they are all in closed files. But if all of us can use it in a forum, and where all the different IIT professors can work with their technologies and establish them and publish the papers, then bamboo technology will become more established. And I really wish that this momentum that we try to create in this webinar does not and give us a lot of benefit in future. Thank you.
Thank you very much, Dr. Gupta. And with the permission of all the eminent speakers and the technical team that is supporting us, I would like to just conclude in 2 to 3 minutes, which may be exceeding our 1.5 hours time by 1 or 2 minutes. But I would like to take advantage of the excellent presentation as well as the insights given by our speakers today. And for the benefit of all our participants, I would like to mention here that one of the largest NGOs or organizations which is working in the field of bamboo internationally is INBAR, that is International Network for Bamboo and Rattan. And for some of you who may not be aware, that INBAR was an IDRC project which started in a project mode from India, from the Southeast Asia Office of India. And Dr. Cherla Shastri, an IDRC employee who was the leader of that project, went on to become the first Director General of INBAR, which moved to Beijing. Unfortunately, because of some communication gap or maybe due to oversight, that the land required for the construction of building was not available at that time in Delhi. However, the then Environment and Forest Minister Shri Suresh Prabhu, who took over soon after the INBAR was established in 1997, he was the first visionary in terms of policy makers of our country to ensure that the role of bamboo and its importance in the second largest acreage of land under natural bamboo plantations in the world, India should take a lead. And under his initiative, India became not only signatory of the INBAR Treaty, which is now one of the 50 plus countries of INBAR signing signatories, but also ensured that the first bamboo mission was established in India and went on to influence Honorable Atal Bihari Vajpayee to ensure that there is a 4,000 crores of rupees of fund made available in the budget of central government for bamboo development in India under the bamboo mission. INBAR, of course, is functioning independently now in Beijing, but India, in terms of its first Director General and also the organizations and the speakers that we heard today, are providing leadership to bamboo development of not only in our country but also to the world. And therefore, with the initiative that we have taken through formation of a conglomeration and a consortium of experts, we would like to involve all of you in our future activities also, and would like to invite suggestions from all of you as to how this forum can efficiently and effectively function in future. With this, I would like to thank IIT Delhi and also KONBAC for taking initiative and also forming a forum which will have its own website and interactive provisions, and the technical team who has given fantastic support with an uninterrupted supply of the visuals as well as the audio. And I would like to thank the technical team as well, headed by Shri Shilpesh Gambhire. With these words, unless our experts have to offer any final concluding comments, I would like to declare the successful completion of this webinar, and we will come back to you soon with not only sending you the answers of all the questions that you have asked, but also from submitting from time to time the suggestions that you have given, the implementation of that, and a schedule for our future activities. Thank you very much, one and all. Thank you all the participants from India and abroad. Thank you very much.
Thank you. Namaskar.
Thank you.
Namaskar.
Thank you.